One great website that I like to use is Wolfram Alpha, wolframalpha.com. It's a fun website. I think I showed it to you guys day one. I can't remember. But you can type in, okay, well, I'll just tell you. You can type in a whole mess of things. You can type in math things. You can say factor this polynomial and blah, blah, blah. But we're going to type in, where is it at? Yeah. We're going to type in number of cattle in Europe. Boop, 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 boop. And then Wolfram comes back and says, there you go. It gives you the livestock populations of many of the countries within Europe. Let me make that go bigger, more. So there's the top 10, and we can get more data if we wanted to. Actually, let me hit more one more time. So what we're going to do is learn how to draw the corresponding histogram. We're not going to draw this guy. That's a dot curve or dot graph. It even does a nice graph showing the population density. It's a very nerd-tastic site. So it's not just math. It's a whole bunch of other things. So if we have these values, the 18.6, 12.9, 9.9, the entire list, collectively, that's called a data set. Now we can take subsets of it, meaning let's suppose we just had certain values and just use those. So I think on your PowerPoint it says, yes, between 1 and 10 million. Thanks. So let me scroll this down a little bit. Serbia, you got in there. Congratulations. So this right here, because we want to go from 1 million to 10 million, this would be considered the data set. So everything from United Kingdom all the way down to Serbia, that will be the data set. So just the data itself, we would say 1, 1.35, all the way up the line. The thing to note is that every data point represents a different country. Also, you'll note that we have some repeated data. We have two 1.54s. That's okay. Mike, yeah. Do we really have to write all that? Yeah. Thank you for the opportunity. You're welcome. Notice in our data set we use braces. Now on your test and your homework, whatever else, the data is provided for you. I'm not going to make you research anything. But in a stats class, they might have you go, they might give you a research project where you have to go out there and find the data. So Wolfram Alpha is great. There used to be a fantastic website that got taken down recently, census.gov. So all the census results every 10 or 20 years, whatever it is, would be posted there. So unfortunately, they took that out, which was very sad because it was a good, really good source for data. All right, cool. So I think that's the first slide. What are the data set related to 1 to 10 million? Let me go to the next slide real quick, if it lets me. Oh, I know why, because it put it all the way at the end. That's nice. Make a stem and leaf graph for those countries between 1 and 10 million. All right, I'll do that now. So what we're going to do now is we're going to turn this data into what's called a stem and leaf graph. You'll see that as we progress, we start to lose the individuality of the data. Because by grouping the data together, we lose what the individual countries are saying. So as it stands right now, those are the individual countries, which is great. But notice we lost the names associated with those individual countries. That's what happened. But what we're going to do is start to make this data visual. And one way to do it is what's called a stem and leaf graph. In a stem and a leaf graph, you make a chart. On the left-hand side, we have the stem. And the right-hand side, we have the leaves. Depending on the problem, the stem is typically the repeated numbers. So what I mean by that is we have a lot of numbers that start with 1. We have a lot of numbers that start with 2. We don't have any that start with 3. That's okay. 4, 5, 6, no 7s, no 8, and then we have 1, 9. So for this problem, the stems would be the whole part, 1 up to 9. Well, actually, we'll be skipping the ones that aren't there. So the stems for this one are the whole part. Whereas for people's ages, for instance, if you even have like a decimal portion of their age, which would be a little weird, probably the age itself would be the whole part and the decimal portion would be this leaf. Just like here, our leaves are going to be the decimal portion. So for the first one, the number is 1. What's the decimal portion? 0. To keep everything uniform, we're going to use 2 digits. To make a separation between them, please put a comma. I think in our textbook they leave a space. That gets very confusing visually, so please put commas. The next one, instead of 1.35, we just write the 3.5 because we already wrote the 1 to the left. Comma, what's the next one? Next one? 54. We got another 54, and then 60. So that first row takes care of every element that starts with a 1. Now we have a 2, so we're going to start this off with 0, 0, then what? 54, 68. We don't have anything that starts with a 3, so we skipped it in the stem. Go right to the 4. 0, 0. Good. 5. 0, 8. Good. 7, 0. 6. Good. Good. And 9 is just 0, 0. I'm sorry? Was it 9.9? Oh, I'm sorry. So 990. Thank you. All right. So that's a stem and leaf graph.